Hi guys, I'm Kathryn and I'm going to teach you guys how to balance a redox reaction in an acidic solution. So this is number 172 on the problem set. So it says, complete and balance the following redox reaction. What is the coefficient of H2O when the equation is balanced using the set of smallest whole number coefficients? And the reaction is MnO4- plus SO3 2- yields Mn2+ plus SO4 2-. So first of all, a redox reaction is basically dealing with the transfer of electrons from one atom to another. So the first thing that we're going to do, since we already have the reaction, we're going to write the half reaction. So let me go ahead and do that. So we have to figure out which one's the reduction part and which one's the oxidation part. So if you put these two together and these two together, those will be the half reaction. So let's go ahead and do that. So it's MnO4-, and let's leave a little space, yields Mn2+, and SO3 2-, leave a little space, yields SO4 2-. So as you can see, these will be our half reactions. So now what we try to do is balance these out. So first let's balance out the MnO4 to the Mn2+. So what we can see is we need 4 oxygens on this side. So we're going to add 4 waters. And now that we have 8 hydrogens on this side, we're going to put them on the left side where the MnO4- is. So it's going to be, so now we're going to have 8H plus MnO4- yields Mn2+ plus 4H2O. So now you can see that everything's balanced. So now we have to figure out how many electrons are transferred from each one. So here you see that we have a positive 8 and a negative 1. So the total charge for this side will be a +7. And on this side we have an Mn2+ and a 0. So here we're going to have a 2+ overall charge. So you can see that from +7 to +2, sorry, not 2+, +2, so you can see that you're here, from here to here, you're gaining electrons because you're going from a bigger number to a smaller number. So now that you think about that, this would be the reduction side of your half reaction. This would be your reduction half reaction. So obviously this would be the oxidation side of your reaction. So now let's balance this one right here. And from here we're going to put 5 electrons minus. So now you see here that we have an SO3 2- and an SO4 2-. So what we can do here is add an H2O to this side so that we can get another oxygen. And now we have 2 hydrogens, so we can add 2 hydrogens to the other side. And from here, everything seems balanced. So now all we have to do is see how many of the electrons transfer. So from there, you can see that it'll be a 0 charge to a 2-, so that's 2-, and then a 2+ and a 2- together. So here it's 2- and a 0. So it's losing 2 electrons. So we're going to put it on the right side. So now from here, we can put all of these reactions, put these 2 reactions together, and we'll make the whole reaction to find the coefficient of H2O. So as you can see, there's a 5e and there's a 2e. So what we can do to balance those electrons out, we can multiply this whole thing by 2 and this whole thing by 5. So now let me change colors and let's write out the reaction. So now we'll have 16H plus 2 MnO4- plus 10 electrons plus 5 H2Os plus 5SO3 2 minus yields, and let me go ahead and write this part at the bottom, 2Mn 2 plus 8 H2Os plus 5SO4 2 minuses plus 2 H plus 10 electrons. Okay, so now you see that's a pretty long reaction, but now we have to simplify everything else. So I'm going to go ahead and erase, so if you want, just pause it so that I can erase it, and then I'll rewrite this equation up here so that we can simplify everything together. So it's the 16H plus 2MnO4 minus plus 10 electrons plus 5H2O plus 5SO3 2 minus yields 2Mn 2 plus 8 H2O plus 5SO4 2 minus plus 2H plus 10 electrons. So now we have that, and we can go ahead and simplify. So as you can see here, it's basically like algebra combining like terms. So now we can cancel out the 10 electrons on both sides, and now you can get the 16, and you have, let's see, let me go ahead and do this here. This will actually 10 H plus, sorry, copied that wrong. So now you're going to have, since you have a 16 here and a 10 here, you can cross this one out, and this will become a 6 H plus. And then you'll have the plus 2MnO4 minus, since those are different. And then you'll get you'll see here that you have a 5H2O, but then you have an 8H2O here. So then those will cancel out, and this will be on this side. So this is going to turn into a 3H2O. And then you're going to add the 5SO3 2 minus yields 2Mn 2 plus 3H2O plus SO4 2 minus plus 10 OH minus. So now that we've done that right there, an OH plus. So that turned into 10 OH plus. 10H plus, sorry. And this will be 10H plus. So now that we see here, this is our completely balanced equation, our balanced reaction. So now to see that this is fully balanced, we can see how we can prove that is to see if it's balanced by charge. So now you have plus 6 here, you have minus 2, and you have minus 10 right there. So then in total you'll have 6 minus 2, so that's 4 minus 10 is negative 6. And on this side you have 4 plus 4, a 0, minus 10, and plus 10. So now you have, so this is a 0, plus 4, and then minus 6, so it's negative 2, and so plus 4, 0, negative 10, plus 10. So then it's going to be negative 6 altogether. And the answer choice for this one is going to be 3 H2Os, which is answer choice letter A. Okay, I hope it all made sense to you. Sorry I had to keep erasing, but thanks for watching.